So in this example, we're given a couple of different trig expressions to simplify. I'm going to start with part A here. And so we're looking at cosine squared x plus, and then we've got this big product, tangent times sine x times cosine x. So I would focus my attention on this huge product right here. And I'd think about trying to simplify that. So what I'd like to do first, and I mentioned this in a previous video, a lot of times when you're trying to simplify, a good approach is to write everything in terms of sine and cosine. That's not always the best route, but it often is. So knowing the ratio identity will make me think of taking this tangent x and writing it as sine over cosine. Sine x over cosine x. So I'm going to leave everything else the same for now. So I've still got this cosine squared x here. Change tangent to sine over cosine. I'm leaving everything else the same. So now I've got cosine x in the denominator and then times a cosine x over here. So those are going to cancel. I've got a cosine x in the numerator and the denominator if I multiply this out. Because multiplication and division are inverse operations, the cosine x will cancel here. So that leaves me with, so still cosine squared in front. I haven't done anything with that. And now we've got sine x times sine x, and so that's sine x squared, which we write as sine squared x like this. And again, so this is why you want to start this section by memorizing the trigonometric identities, because you want to be able to recognize stuff like this when you run into it. So cosine squared plus sine squared is equal to 1. That's like the most fundamental of the Pythagorean identities. And so the answer to part A, this expression simplifies to 1, but it's going to be critical that you can show the steps, that you can show why that original expression is equal to 1. Okay, now with part B, we're given cosecant x minus cosine squared x times cosecant x. You could do what I said before and write everything in terms of sine and cosine. So we could turn these cosecants into 1 over sine as a first step. But what I think might work better in this case is to factor out this common factor of cosecant x. We factor that out. That's going to be a better approach in this problem. And as far as, how am I supposed to know that factoring out is a better approach? It's going to come with practice. And again, I'll say that this will work. If you turn cosecant into 1 over sine, here and here, you'll still get to the right answer. It just might be a longer path. If I factor out cosecant x from just cosecant x right here, then that leaves a 1 as like a placeholder. We need to hold the spot of that cosecant x. And then minus cosine squared times cosecant, so that'll leave just the cosine squared. Okay. Now, again, just knowing the trig identities is going to help you a lot. So if you hopefully recognize something here, 1 minus cosine squared is equal to sine squared x. This is another one of those Pythagorean identities. And let me write something off to the side. So if you just know this Pythagorean identity, sine squared plus cosine squared equals 1. If you move the cosine squared to the other side with the 1, then the cosine squareds go away here, and you have just sine squared is equal to 1 minus cosine squared. So the identity that I'm using in this step right here is just another version of the identity that I used right here. Cosine squared plus sine squared equals 1. It's just another form of that equation. Okay, but I still have cosecant x. Maybe I'll use red. I'll stay with red on this. I still have cosecant x here. So I need to simplify this. So now I would go ahead and turn that cosecant into 1 over sine x. And this is times sine squared x. And now I have a factor of sine x in the numerator and the denominator. So that'll cancel this sine x. Because I have 2 sine x's here, it's like sine x times sine x. This is only going to cancel one of them, so it's going to leave 1 power of sine x in the numerator and just a 1 in the denominator. So final answer for part B here is just sine of x.